Hello Algebra 1! Today we are going to be simplifying some more square roots and just doing some practice from our last lesson. So the first thing we want to do is practice our perfect squares. What you want to go ahead is take a minute and pause this video and see if you can fill in these first 12 perfect squares. Go ahead and pause that video now and then click on back when you think you have your answers. Alright, welcome back. So here are your answers. The big thing you want to remember is that perfect squares lose their radical once you evaluate. So that's what makes them perfect. They no longer need a radical. So go ahead and check these answers and then we're going to move on to some non-perfect squares. So we're just going to re-practice how to do a factor tree with number 1 and number 2. Remember, you can use any numbers you want as long as they multiply to the inside number. So I'm going to go ahead and use 9 and 2. You're going to find if you use a perfect square, it usually makes your factor tree a lot shorter. So that's why I'm using 9 times 2 instead of 6 times 3, because 9 is a perfect square. It breaks down to 3 times 3, and now I have a pair of 3's. I'll circle cross out, and the 2 does not have a pair, so it gets underlined. Again, underlines go under the square root, circles go out front. And there you go. 32, I'm also going to use a perfect square. I know that 32 is 16 times 2, and 16 is 4 times 4. Now, if you'd like, you can stop right here. You do have a pair of 4's, and you can do circle, cross out, underline. However, if that makes you a little nervous, you can definitely go ahead and keep breaking down the 4's to 2's. So that is a little more work. Now you have 2 pairs of 2's, and we can circle, cross out, circle, cross out. But again, you're just going to multiply those together and you'll get that 4 that's out front. So either way, 4 root 2 is your answer. All right, so now let's simplify when we have a number in front of our radical. This is something that we started yesterday. Remember, numbers outside the radical do not multiply to numbers inside the radical. So ignore that negative 2 for now, and we're just going to break down our 44, which I know is 4 times 11, and 4 is 2 times 2. I have a pair of 2's, so circle, cross out. 11 doesn't break down anymore, so I'm just going to underline it. Underlines go under the root. That 2 will come out front, but don't forget about the negative 2. It's going to multiply to our 2 out front. So it's going to be a negative 4 root 11. Okay, let's try that again. 6 root 20. 20 I'm going to break down. It's just 5 times 4. 2 times 2. 5 doesn't break down anymore, so I look for my pairs. I have a pair of 2's, circle, cross out. 5 gets underlined. Again, underlines go under the root. And then we'll bring down the 6 and multiply. So it's not a 2 root 5, it's a, 12 root 5. Okay, again, that 5 stays where it is, doesn't multiply to the 6. All right, now let's look at number 5. This one's a little different because 100 is a perfect square. This is something you should recognize. This is just a 10, not a root 10. So I'm just going to bring down my 11. 11 times 10 is 110. Okay, notice again there's no root because square root of 100 is a perfect square. All right, let's try that again. 36, you should recognize this. This is a perfect square. It's just 6. 6 times negative 3 is negative 18. Number 8, you have this root negative 20. What does that mean? It means this is undefined. Finally, 2 root 30. Let's break this down. 30 is 10 times 3. 10 is 5 times 2. Well, this is weird, right? You don't have any pairs here. So that means nothing can come out. You're just going to re-multiply all these together. 5 times 2 times 3 is 30. It goes under the root. That's exactly what it was before. 2's out front. This is all you can do. This was already simplified. All right, and there you go. That is a recap of how to simplify square roots, and I hope you have a great day. Bye.